Alrighty, here we go. I want you to take out your packet that you got that had these two appendix lessons, both A8 and A9, that go together. A8 is this one that said property of translations. Okay, we had talked through a lot of this first front matter, and then I assigned you this last page. So just to help you remember, to transform something means to change it somehow. And we're talking specifically about some kind of geometric shape in math. And the starting point or the starting image is called the pre-image. And then you change it somehow, and then they call it the image. Pre and then image. Some books will call this the post image, pre and post. Sometimes that makes more sense to me because then it's really clear what was before and what was after. But this prefix should help you clarify that. This book just calls it pre-image and image. So pre means where you're starting, the before. This A8 is just talking about translations. So we're just taking it and we're sliding it into a new spot on the coordinate system. No spinning it, no flipping it. We're just leaving its orientation the same and moving it somehow. And your job is to describe mathematically how are we moving it. Okay? Now we went through some of this front matter stuff here. And so I need you to get to the page that I assigned you, which was these practice problems. And I want to check these over with you. All right? It says, what type of translation, so that means a slide, was performed here? Okay? And so we know it's a slide. They want you to describe it. Okay? And so here's what happened. When you start looking at K to K prime, that's what we call it with the little accent mark there. How do we move? Now it looks like it's going diagonally. You describe it to me horizontally and vertically. Like pretend you only have streets that run horizontal and vertical. So it looks like we had to go bloop, 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 3 to the right. Okay, so we moved 3 units right. And then we went up, okay, vertically. So 3 units to right, and then 1, 2, 3, 4 units up. What happens to the x coordinate from the pre to the post? So let's take a look at this original k. This original k had an x coordinate of -3, a y coordinate of 2, -3, 2. My new k, k prime up here, and I'll even change colors to make this guy look green, okay? I guess I should have used blue on that one. This new one is at 0 and +6. Those are the coordinates of this guy. So I went from -3, 2 to 0, 6. What happened to just the x coordinate? From -3 to 0, you added 3, okay? Or you increased by 3 to all of the x coordinates. Now for k, I added it to -3, but all of the other coordinates also had 3 added to the x coordinate. Look at then the y coordinates. Aha, the change in the y coordinates, I was at a level of 2 and now I went to 6. You added 4 because we went up 4. So you added 4 to the y coordinates, to the y coordinates. That's because we went up, we added, okay? All right, now let's look at 2 and 3. Here, you have to draw the image after the translation. So we have to make this go 4 units to the left and 2 down. So check yours. Start with P. 4 to the left, 1, 2, 3, 4, and down 2. I can't call it just P again. We call it P prime. So we put a little, what looks like an apostrophe or an accent mark there. Q, 4 to the left and 2 down will be right there. R, 1, 2, 3, 4, down 2. There's your new R, the image. And S, 1, 2, 3, 4 to the left and down. Excuse me, there's S. All right, connect it. It should look just like it. It's not bigger, it's not smaller. It didn't shift in its orientation. It's the exact same thing, just in a new location. All right. They're not asking us for the coordinates, so we can just leave it as is. A, B, C, D, 5 to the right and 3 units up. 1, 2, 3, 4, 5. 1, 2, 3. There's your A prime. 1, 2, 3, 4, 5. Up, 2, 3. There's B prime. 1, 2, 3, 4, 5. 1, 2, 3. There's C prime. And that's good because B and C were exactly underneath each other. 1, 2, 3, 4, 5. Up, 2, 3. Hey, D ends up, or I should say D prime ends up exactly at the origin. Cool. There you go. Okay, the last one, now this one was a little tougher. This is my image. You have to go backwards and figure out where did this come from so that your translation was 5 to the right and 7 up. Haha, 7 up. Okay, so this is where you ended. So we got to go back 5 units to the left. 1, 2, 3, 4, 5. And then go down 7. 1, 2, 3, 4, 5, 6, 7. I believe that's where P started. Double check now. If I go 5 to the right, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. Yep. There's P. That means Q was right here. And that means S. Looks like S would have been down there. And R down there. Ba-doom, ba-doom, ba-doom. There you go. Cool. Now, we got that one done, so you should have double checked and corrected and made sure your work was accurate. So when I breeze through after I collect these, then I should be able to just look at this and see that you corrected and got that accomplished. Now what I want you to do is flip to the next page in your packet, which is actually then A9. This one is also a transformation, like these guys, transformers. But this one is a reflection. A reflection is a mirrored image, okay? And what happens is now we're going to flip. Now you're going to flip. Here you go. Flip. So you flip it, and we need to know exactly what you're flipping it across. So we draw a line somehow and we indicate that. And that is what we call this line of reflection. Okay. If you ever did any kind of artwork when you were little, where you took some sort of piece of paper and then you folded it, okay, that would be your line of reflection. And then you could like paint something on here just on one side, and then you folded it over, and it's like it inked it over on this side and reflected it, created that same drawing, but a mirrored image. Kind of cool. Well, we're going to do the same thing. We're just doing it in a mathematical way on a coordinate grid. So take a look at this one. Here's a triangle. All right. And it says trace triangle ABC onto a piece of paper. Well, I think you can actually do this visually without having to do this step. Here's triangle ABC. This is going to be our pre-image. If you can envision folding your paper along the x-axis, this is the x-axis, the horizontal one. And if it helps you to draw along there on the line, what I need you to envision is if you fold this and fold it up, where is this triangle going to land over here? Okay, now can you visualize this? Let's start with A. A right now is 1, 2, 3, 4, 5, 6 units away. When I fold this, this is going to plop and end up here 6 units on the other side. This is A prime. B right now is 2 units below the x-axis. It's going to land 2 units above. There's B prime. C is 2 below. This should be 2 above. Here's your new triangle, and that's the reflection. Okay. Here are the coordinates. What's the line of reflection? It's the x-axis. It says find the perpendicular distance. Perpendicular means, remember, forming a right angle like that. So it wants the distance from each point to the line of reflection. When you look at A was 6 units away. Excuse me. Both B and C are 2 units away. How about A prime? That's also 6 units away. It's just above. B and C. Coffee. Those are also 2 units away. They're just simply above the line. B prime and C prime. So what do you notice about the distances? They're the same. From A to A prime, B to B prime, C to C prime. Okay? Now, let me change color here. Do the same thing. Visualize going across the y-axis. So let's do this. Go across the y-axis. Okay. Now, go back to the original. So that's this one down here. Now I want you to envision folding it this way. So now you're going to take that triangle and flip it across the y-axis and label it. And this time, since we already used A with 1 accent mark, when we do A over here, it's 2 units away, so make it 2 units away here. They said do this, put 2 accent marks or apostrophes, and we read that as A double prime. Now let's do point B. It's 2 units away from my fold line, so make it go hop 2 units this way. There's B double prime. And C. C is over here. Let's see, 1, 2, 3, 4, 5 units away from my fold line. So make this guy 5 units away over here. C double prime. Connect, connect. Notice I have shifted it. I've flipped it, but it's still the same size. Okay, the orientation has changed because now it's kind of this mirrored image. But I haven't changed the size at all. I didn't enlarge it. I didn't decrease it or shrink it. It's still the same size. What's the line of reflection? The y-axis this time. I guess I only need 1 hyphen there. How does each image in your drawings compare with its pre-image? Same size, but it is flipped. It is flipped in some way, and it might be shaped, it might be flipped horizontally, or it might have gotten flipped vertically. Okay. All right. You can look at some of these examples that they gave you here. Okay. But what I want you to do basically is now let's start looking at these at the coordinates, see how it's flipped and see what's happening to the coordinates. So we're looking at the numbers this time. This is a reflection because it says what type of reflection. Okay, it's a reflection across what line? If you can find that symmetry line, it's this one, and it's the y-axis. Make sure we put that in there. Now what I want you to do is start peeling off the coordinates of the pre-image. That's this side. So when you look at T, T is at -4, +6. R is at -2, 5. A is at -2, 3, and P is over here at -4, 1. Now let's look, and again, I'm going to make this purple and then I'll switch color so we can keep track of stuff here, okay? Green. Now let's look at the image. Look at where T prime landed up. 1, 2, 3, 4 at +4, 6. +4, 6. P, or I'm sorry, they went to R next. Let's find R. R is at +2, +5. 2, 5. A prime is at 2, 3. And P prime is at 4, 1. Positive 4, 1. Interesting. Negative 4, 6, positive 4, 6. Negative 2, 5, positive 2, 5. Negative 2, 3, positive 2, 3. Negative 4, 1, positive 4, 1. What happened to the x-coordinates? My x-coordinates are changed, but they are the opposites. So the x-coordinates are the opposites. Describe the change of the y-coordinates. The y-coordinates had no change. So how did the reflection across the y-axis affect these coordinates? Well, the x-coordinates became opposites. The y-coordinates were unchanged. Then it says, now, guess what? If we took this image, okay, we reflected it across the y-axis, but when you did that and reflected it this way, it didn't move up and down. It just changed. Your horizontal coordinates are the ones that changed. So now it's asking you, what if we had folded it across the x-axis? In other words, flipped it downward. This time what would happen is this time your x-coordinates would stay the same. However, and the y-coordinates would be the opposites, would become the opposite value. Cool. Cool. All right, so here's what I want you to do. Your work or your assignment is to practice these. There's only about 3 questions on here, so it won't take you that long. And then when you get done with that, I want you to practice all of these skills in IXL under the X's. And you're specifically going to do X3, X4, those are on translations, X5 and X6 are on reflections. Alrighty, good luck, and may the force be with you.